In this video, we're going to take a look at using Nashpy and the support enumeration algorithm to quickly find Nash Equilibria of games. So I'm putting Nashpy and I'm putting NumPy. Here I've got a 3x2, well, two 3x2 matrices to create the same game that we've looked at in a previous video. And so I'm going to now create the game using Nashpy. And let's take a look at it. We get that bimatrix game with the pair of matrices. And then I'm going to create a variable called equilibriums or equilibria, depending on what you think the right answer is. And we create game, and we run the support enumeration method on that game. And now what these equilibria are is actually a generator object. And so this is an important thing to make a note of. The way Nashpy works is that when it does any heavy lifting, it doesn't try and do it immediately. So this is just a generator object. You could have a huge game, and you could create this generator object in as much time almost as I've just done there. And what it essentially is all the instructions for the algorithm. So it's taken the generic definition of the algorithm, and it's created the specific version of the algorithm for this game, but it's not actually stepped through it. And this is important, and Nashpy tries to do this wherever it can, so that you can handle big objects. And one advantage is that maybe you don't want to run the whole algorithm for all possible pairs of supports. You just want to find the first equilibria, and in which case you could use next to just step through it. And so if we run next, it's giving us the first one it's got there. And as we found in a previous video, the equilibria for this is 2/3, 1/3, and 0, 1/3, 2/3. And note that if we do next again on the equilibria, nothing's in there. So we've essentially emptied it. And indeed, if I did list of EQs, it's an empty list. And that's another way of stepping through the equilibria, is if I restart the support enumeration algorithm and I do list of EQs, it'll immediately step through and calculate all of them. There's only one there, but if you had a game with a lot of equilibria, that would be a useful way of getting all of them. And that's, again, an important design decision within Nashpy. It does that so that it doesn't keep any equilibrium in memory unless it needs to. And that's how we use Nashpy and the support enumeration algorithm to find Nash Equilibria.